Daenerys is a great example. I think this has come up once or twice throughout the day as well. Oil and gas tracking capability, where we developed novel mechanical systems for applying passive UHF tags within these oil and gas pipes. We're working with SAP to integrate this data into their ERP, and it's a very successful custom solution. All right, finally, novel solutions. And this is not only high risk, but extremely high reward. Because when individuals take the initiative to think, how can I leverage RFID within my enterprise in new ways, it really opens up a new world of possibilities. It tends to require new product development, not only on the hardware side, but on the software side. And it requires a bit of vision. Potential pitfalls: make sure that you document requirements clearly. It's one thing not to know for sure what the hardware answer is going to be, but it's another thing to define exactly what the final solution should be capable of doing. Be sure to get that down up front. The second thing I'd say is make sure you're gathering end user feedback as the development process is underway. So for example, let's say we're in an A380 and we want to capture RFID, passive UHF RFID tags, but we want to know where we are in the aircraft when we capture those tags. So let's say we want to integrate an RTLS tag with our handheld. So we know where we are within the aircraft, and then we can scan the tag and know exactly where that data was captured from, because that's important to the customer. Don't wait until the hardware is completely finished and integrated and molded. Instead, tape an RTLS tag to the handheld and go through. In some cases, this is intuitive, but make sure that you don't delay getting that end user feedback and input. And then finally, make no assumptions. Just because RTLS works in a warehouse doesn't mean it's going to work in an aircraft. And it certainly doesn't mean it's going to be certifiable within that environment. There are a lot of EMF regulations that have to be accounted for in an aircraft. So don't make any assumptions. Make sure you research those things out. This is an example of a client who came to us because we had patented technology around smart container capability. So this is a brand new capability that the industry has yet to see. And the goal here is, as standard ISO shipping containers are being loaded, the client wants to automatically update the contents of the container. Very inventive, very innovative. So we've created what we call the Easy Portal. And actually, why don't I just first go through the requirements. Again, automatically capture the inventory of the container, very high accuracy. This system has to be installed in less than a minute because, let's say you don't actually own the containers, but you're renting them. So you want to be sure that it can be taken in and out of the container very rapidly. So it has to be installed in less than a minute. It has to be battery powered for up to a year. And hands-free operation. That means no human involvement. These are non-trivial requirements. And it takes some guts to stand up and say, we want to make this a reality in our world because it really isn't proven anywhere else. So I just wanted to briefly show you a video of the process of installing this system. This is Christine. I think you've seen her around. So the system magnetically couples to the walls of the container. It, as you see in the top, the yellow body contains all the intelligence of the system, the reader, the single board computer, the battery system. The black units are embedded antennas. And as I mentioned, it all magnetically couples to the wall, which is how we're able to install it in less than a minute. You can imagine the impact this could have, not only for the Navy, but for the private sector as well, as we're getting below the container. So today, the military has what they call in-transit visibility, meaning the container is tagged. They know where the container is in the world. But the moment that seal is broken, they have no idea what's inside. So this will enable total asset visibility in a very new and innovative way. Okay, principle number 2, clear communication is key. Daniel walked through this a bit earlier. I just wanted to remind you that it's very important to have a coordinated approach within your team. And this is an approach that works extremely well for the first two solution types, the off-the-shelf solution and then the custom-built solution. We've been using it for years over hundreds of different projects. And I'm not going to belabor it because I think Daniel covered it earlier. but it's a very effective approach. Kevin mentioned this a bit earlier. This is the home screen of a tool we called Easy. He was referring to it as Easy Monitor. Before Easy Monitor is fully populated, in the design process, it's called Easy Reader. And the moment we flip the button to monitoring, it becomes Easy Monitor. What I'm going to talk to you about is Easy Reader, which is that process leading up to what Kevin was describing in the monitoring capability. And I'm going to walk you through some of the screens that we use to design the solution. This becomes a very powerful communication tool that you can use to coordinate your team activities. So as he mentioned, we use it to plan the deployment, to actually lay it out physically, to procure the bills of material. And you'll see that particularly when you deal with hundreds of read points across dozens of facilities, this can become very complex and difficult to manage, which is why it's important to use a centralized repository. Procurement, installation, I'll actually show you some of what we do to then tune the system. And then finally, I won't really cover support because Kevin did a nice job of addressing that a moment ago. So as he mentioned, we can actually import a floor plan. It's very important to know where on the floor an installation is going to go. This is actually, this is one of our clients. You can see the high-speed conveyor in the center there. You can see an interrogation zone set up. Once the floor plan has been implemented, we can then use standard, this is actually a wizard that we use, to determine what type of infrastructure is required in these specific implementations. So in this case, we've selected to implement a dock door portal, common in distribution centers. We use this commonly for the DLA rollout. And 4 different types with 4 different bills of material. Here we have 2 readers on this side. This reader is driving 2 antennas in this rack and 2 in this rack, and then another reader on the opposite side. You can see how there are a number of different combinations depending on the type of situation, whether you have adjacent dock doors or not. Here's a situation where the dock doors are very close together, and so we can use 1 reader per rack. And this way we can very easily and automatically manage the bill of materials that will have to be procured. Any questions about this? So the next step is once we've actually physically installed the system, we can use Easy Reader to automatically tune the system. Not only tune, but then test it. We have the ability to measure radiation patterns to verify that we have no nulls in the zone. And here you see a use case set up as a dock door. And based on the reader power, the zone geometry, the product velocity, the data rate, etc., the reader is automatically tuned for that particular use case. So, clear communication is key. Those files then, the Easy Reader files, then become a way of making sure that the people on the floor, the operations folks, understand exactly how their physical environment is going to change. It can be used to then show your management team, here's what we've actually deployed, and this is the final outcome. Okay, and finally, measure twice and cut once. I wanted to walk you through some of the decisions that we make when we're designing an RFID system and also help you understand why it's important to do some specific testing. Readers, theoretically, emit about 30 dBm at the port in North America. We then connect a cable there that introduces some loss. And an RFID system is all about power management. It's about getting power out to the tag and then effectively receiving power back from the tag. And managing that forward link is particularly important because these systems tend to be forward link limited, meaning if you can activate the tag, then you can hear the response almost invariably. So understanding the losses due to cable between the reader and the antenna is important. Understanding the gain that you receive from the antenna is also important. And then the losses over space between the antenna and the tag, obviously that varies.